Hello everyone. In this second part of semiconductor diode series, we will talk about types of semiconductor. At the end of this video, I have given important questions of types of semiconductor which will help you for further study. So let's begin with the video. Semiconductors are classified as intrinsic semiconductor, which is also called as pure semiconductor, and extrinsic semiconductor, which is called as impure semiconductor. Further, extrinsic semiconductors are classified as p type and n type. So let's start with the intrinsic semiconductor. Intrinsic type of semiconductor material is in pure form, means it is made up of only one single type of element. The presence of impurity, means atoms of other material, is very low, and therefore they are equivalent to insulators or very poor conductors. Germanium, silicon are the most common types of intrinsic semiconductor elements. Semiconductors that are chemically pure, in other words, free from impurities, are called as intrinsic semiconductors. The number of holes and electrons is therefore determined by the properties of material itself instead of impurities. In intrinsic semiconductor, the number of excited electrons is equal to number of holes, and therefore they are termed as undoped semiconductor. Now let's go for extrinsic semiconductor. Extrinsic means impure. We can say that intrinsic semiconductor plus added impurity is equal to extrinsic semiconductor. The process of adding impurity to the pure semiconductor is called as doping. Due to doping, the conductivity increases. Two types of dopants are used. Pentavalent atoms, means the atoms with valency 5 such as arsenic, phosphorus, antimony, etc. Or trivalent atoms, means atoms with valency 3 such as indium, aluminium, boron, etc. So this is about extrinsic semiconductor. Now let's compare intrinsic and extrinsic semiconductor. Here the comparison of intrinsic and extrinsic semiconductor is given. Intrinsic is pure type of semiconductor because there is no impurity present. Extrinsic is impure. In case of an intrinsic, the density of electrons is equal to density of holes, means number of electrons is equal to number of holes, but in case of extrinsic it is not equal. In intrinsic semiconductor, as it is a pure semiconductor, the electrical conductivity is low. So or in extrinsic we can call as electric conductivity is high. Intrinsic are dependent on temperature only. Extrinsic are dependent on temperature as well as on the amount of impurity. And as I told you, in intrinsic semiconductor, no impurities are present. But in case of an extrinsic semiconductor, trivalent and pentavalent impurity we can use. Now let's discuss about extrinsic semiconductor in the next slide. The dopants in extrinsic semiconductor give rise to two types of semiconductors. They are N type of semiconductor and P type of semiconductor. As shown in the figure of N type of semiconductor, the tetravalent atom such as Si is doped with pentavalent atom Pb. The four of the electrons of the pentavalent atom with the four neighboring silicon atoms will create a bond. The fifth one remains weakly bound to the parent atom. As a result, the fifth electron is free and the electron become free to move in the lattice of the semiconductor. Such semiconductor are termed as N type of semiconductor. Here donor impurity contributes free electron. As shown in the figure of P type of semiconductor, when a tetravalent atom such as Si is doped with trivalent impurity B, the dopant atom has one less electron than surrounding atoms of Si. Thus, fourth atom of the tetravalent atom is free and a hole or vacancy is generated in the trivalent atom. In such materials, the holes are the charge carriers and such semiconductors are termed as P type of semiconductor. Thus, we can say that the acceptor impurity creates a hole over here and therefore it is called as P type of semiconductor. We can say that holes and electrons are basically the charge carriers of the semiconductor, which results in the flow of current or electricity through it. Electrons carry a negative charge and hole carry a positive charge. So from this slide we can say that in N type of semiconductor, free electron is created or donor impurity contributes free electron, and in case of a P type semiconductor there is a creation of hole, acceptor impurity creates a hole. So these are the types of extrinsic semiconductor. These are the important questions of types of semiconductor. The answers of all these questions you can find in the same video. Thank you for watching my video.